Okay, for this problem, we have the integral from negative power of 4 to power of 4 of 12 times the square root of secant squared theta minus 1. Okay, so the first thing we want to do is use the trig identity to substitute this out for tangent squared. This is the trig identity that I'm talking about here. Okay, so we'll substitute that in, and the reason being is because we'll have a square root and a square, which will in essence cancel each other out. Okay, so let's write that in there really quick. So we get 12 times the square root of tangent squared theta d theta. Now, they will cancel each other out, but just like this rule that says if you have the square root of x squared, your answer is the absolute value of x, then the square root of tangent squared theta is equal to absolute value of tangent theta. Okay, so given that, we can reduce this. So it'll become negative power of 4 to power of 4 of 12 times the absolute value of tangent theta d theta. Okay, so we know that if we didn't have the absolute value there, the antiderivative of tangent theta is the natural logarithm of secant theta. Okay, but we do have the absolute value there, so we have to do something about that before we can proceed in this problem. So what I'm going to do is type this into the calculator. First, I'm going to type tangent in to remind you of what tangent looks like. Okay, and on my window, I am going from negative pi over 4 to pi over 4. And then on the y min, y max, I'm going to go from negative 1 to 1. And that'll give me an idea of what this graph looks like. This is not the absolute value. This is just tangent, okay, zoomed in rather close to the origin there. Okay, so what happens when I put the absolute value around it? Well, we should know by now that it's going to make everything positive, but let's look at the graph real quick. So put the absolute value there, close it up, graph it. Okay, so it makes it positive, and it also creates symmetry about the y-axis. So symmetry meaning that the area under the curve of the right side is the same as the area under the curve of the left side. So instead of going and taking this integral from negative power of 4 all the way to power of 4, we could just go from 0 to pi over 4 of the tangent function. Now, I'm trying to get rid of that absolute value, right? So we could, since this is what it would look like, then we could just go from 0 to power of 4 and double our answer, right? Times 2. Okay, remember that without the absolute value, this goes back down, and that's what we're actually going to integrate. But with the absolute value, it's positive anyway. So we can just take this integral from 0 to power of 4, double our answer, and get rid of the absolute value. So that's what I'm going to do. So instead of negative power of 4 to power of 4, I'm going to go from 0 to power of 4. I'm going to multiply by 2. I still have a 12 tangent theta, d theta here. Of course, that means 12 times 2 is 24. So I have 24 from 0 to pi over 4 of tangent theta d theta. Okay, that takes care of the absolute value. We use symmetry on the graph to get rid of it. Okay, so let's go ahead and take the antiderivative so we can do this integral. So the integral of tangent theta is, like I said earlier, natural logarithm of secant theta. So we get this is equal to 24 ln of the absolute value of secant theta. Okay, and this is going to be evaluated from 0 to pi over 4. Okay, so we've taken the integral. Now we just need to plug in the limits. So we do that by, put the 24 out front. Ln of the absolute value of secant of pi over 4. Remember, that's absolute value. Minus ln absolute value secant of 0. Okay, so we'll look at this one in a second, but let's look at this one first. We've got secant of 0. Remember, secant is just 1 over cosine. Okay, and cosine of 0, so we can replace this when we say that's actually 1 over cosine of 0. Remember, cosine of 0 is 1. Okay, so the inside of this thing becomes a 1. Okay, and what is ln of let's write it here. ln of 1 is equal to 0. So this whole term just goes away. It's gone. So the inside, we write it as 1 over cosine of 0, which is 1 over 1. ln of 1 is equal to 0. So this entire term is gone. It's zeroed out. Okay, so that leaves us with 24 ln of absolute value of secant pi over 4. Okay, now what is secant of pi over 4? Well, we could think of it in the same way we did on the other one. Say, well, that's 1 over cosine of pi over 4, right? And what is cosine of pi over 4? Well, that's root 2 over 2. So 24, let's write that down, ln of 1 over cosine of pi over 4, which is 24 ln absolute value of 1 over root 2 over 2. That's the value of cosine of pi over 4. If we fix this, we put the 2 on top, flip it, and multiply, it'll give us root 2 over 2. So that's 24 ln of 2 over root 2, excuse me. You don't want to leave that there. You want to rationalize the denominator if possible. So we multiply top and bottom by the square root of 2. So this becomes 24 ln of 2 root 2 over 2. Of course, the 2's cancel. So 24 ln of root 2. Okay, you might be able to leave that answer. That's an acceptable answer sometimes. But we could clean this up one step further. Remember, the square root means you are to the 1/2 power. So that's 24 ln. We can drop the absolute value now as well because we know the inside is positive. So we don't need the absolute value anymore. So ln of 2 to the 1/2 power. Now, the reason I did this is because when you have a logarithm rule says that if you have an exponent, you can bring it down out front. So we bring that down out front, we get 1/2 times 24 times ln of 2. Okay, so our final answer is 12 ln of 2.